Hello everyone, I am Banita Maharana, lecturer in civil at SKDB Government Polytechnic, Rourkela. I am taking your Civil Engineering Lab 2. This is in your 5th semester. So, in this video, we shall demonstrate the determination of field density of soil using core cutter method as per Indian Standard Code 2720 Part 29. So our aim of the experiment is to determine the field density of soil by core cutter method. Apparatus required for conducting the test are cylindrical core cutter, steel dolly, then we have steel rammer, weighing balance, steel rule, trowel, moisture tin, thermostatically controlled oven. In this slide, you can see cylindrical core cutter, steel dolly, steel rammer, steel rule, moisture tin, trowel and weighing balance. Field density is defined as weight per unit volume of soil mass in the field at in situ conditions. Core cutter method is used for finding field density of cohesive or clay soils placed as fill. It may be noted here that the field density always refers to the dry density because the wet density of soil at location varies from season to season and based on the fluctuations of the local water table level and surface water. So as the moisture content is likely to vary from time to time and hence the field density also varies, so it is required to report the test result in terms of dry density. Mathematically, field density can be calculated as total weight of the soil sample divided by total volume of the soil sample. Then by using field density and water content of the taken soil sample, the dry density value can be calculated as field density or weight density or bulk density of soil sample divided by 1 plus water content. So what is the need of determination of field density or dry density? Why will we conduct the test to determine the field density value or dry density value? So we need to understand the objective of the test. So field density of natural soil is needed for the determination of bearing capacity of soils for the purpose of stability analysis of slopes, and it is also needed in estimating bearing capacity of soil foundation system, settlement of footing, earth pressure behind the retaining wall, and it is also a quality control test where compaction is required. So for these purposes, we need to determine the field density or dry density value of the in situ soil. Then next come to procedure. So firstly, find the volume of core cutter by measuring its internal dimensions, that is its internal diameter and height. Then find the weight of the core cutter without dolly and without soil, this is W1. Then place the dolly over the core cutter and drive the core cutter into the soil with the help of rammer. Then take out the core cutter containing soil. Remove the dolly and trim off the excess soil above the edges of the core cutter. Then take the weight of the core cutter filled with the soil, that is W2. Then remove the soil core from the cutter and take the representative soil sample in the water container to determine the moisture content and weight the container with soil, that is W3. Then keep the container in the oven and dry it for at least 24 hours at a temperature of 105 degrees Celsius to 110 degrees Celsius. Then remove the container from the oven and find the mass, that is W4, and then calculate the moisture content, that is W. Then calculate the weight of the wet soil or moist soil as W2 minus W1. Then calculate the field density of the soil by weight of the total soil divided by total volume of the soil sample. Then after calculating the field density of soil, calculate dry density value as bulk unit weight or moist density or wet density divided by 1 plus water content. So to start with the practical, firstly we need to determine volume of cylindrical core cutter by measuring internal diameter and height of the core cutter. So let us start the practical for the better understand. Firstly, the inner diameter of core cutter is measured, that is 10 cm. Height of core cutter is measured, that is 13 cm. Then inner dia of steel dolly is measured, that is 10 cm, and height of steel dolly is measured, that is 2.5 cm. Now volume of core is calculated. So we got inner diameter of core cutter, that is D, is equal to 10 cm. Height of core cutter, that is H, is 13 cm. Volume of core B, that can be calculated by area into height. Here area can be calculated by pi by 4 into d square and height is h. So here the diameter value is 10 cm and height value is 13 cm. So our volume of core is calculated as 1021 cm cube. Now the weight of empty core cutter is measured by the help of weighing balance, that is 1012 gram. This is our W1. Then a small area of about 300 mm square of the soil to be tested is exposed and the ground is labeled. Now the core cutter is placed with the beveled edge on the ground. Then the steel dolly is placed over the core cutter and pressure is applied manually so that the core cutter gets embedded in soil. Then the core cutter is pushed vertically by the help of rammer, ensuring minimum disturbance to the soil sample. And the ramming is continued until about 15 mm of steel dolly protrudes above soil surface. Now the soil surrounding the core cutter is removed with an excavating tool. Now the excavation is continued to the bottom of core cutter so that the core cutter can be easily taken out. Now the core cutter filled with soil is taken out from the embedded soil. Then the top surface of core cutter is trimmed with the help of trowel. Now the core cutter with filled soil is weighed by the help of weighing balance, that is 2971 gram. This is our W2. Now the weight of moisture tin is made 0 in weighing balance. Now its weight is neglected. Now extract the soil from the core cutter. Then a representative soil sample is taken from the middle for water content determination by using oven drying method. Now weight of the taken soil sample is measured, that is 18.3 gram. This is our W3. Then the moisture tin with soil sample is kept in thermostatically controlled micro oven at 105 degrees Celsius to 110 degrees Celsius. 24 hours the moisture tin with soil sample is taken out from the oven. And then the weight is measured by the help of weighing balance, that is 16.4 gram. This is our W4. So after doing the practical, the calculation part is done. So firstly, bulk density of soil sample value is calculated. So we got weight of empty core cutter, that is W1 is equal to 1012 gram. Weight of core cutter plus wet soil or moist soil is equal to 2971 gram. Then weight of wet soil or moist soil is calculated as W2 minus W1, that is equal to 1959 gram. Then we have already calculated the volume of soil sample, which is equal to the volume of core, that is 1021 centimeter cube. Then the bulk density of soil is calculated by weight of the moist soil divided by volume of soil sample, that is equal to 1.91 gram per centimeter cube. So for this soil, the bulk density value is 1.91 gram per centimeter cube. After calculating bulk density of soil sample, water content of soil sample is calculated. So we got weight of moisture tin with wet soil sample before drying, that is W3 is equal to 18.3 gram. Then weight of moisture tin with dried soil after oven drying, that is W4 is equal to 16.4 gram. Then weight of water is calculated as W3 minus W4, that is equal to 1.9 gram. Then weight of soil solid is equal to W4 only is equal to 16.4 gram. As we have already made the weight of the moisture tin as 0 in weighing balance. Then the water content of soil sample is calculated as weight of water divided by weight of solid into 100, that is equal to 11.58%. So the water content of soil sample is calculated as 11.58%. Then after calculating water content of soil sample, dry density of soil sample is calculated. So we got the value of bulk density as 1.91 gram per centimeter cube, water content value as 11.58%. Then the dry density of soil sample value is calculated by bulk density divided by 1 plus water content, that is 1.712 gram per centimeter cube. So in this way we repeated the process for 2 more determination and recorded the corresponding values. So the average dry density of 3 determination is 1.721 gram per cubic centimeter. So 1.721 gram per cubic centimeter is the dry density of the soil sample taken from the field. So students, in this way we can determine the in situation dry density of soil using core cutter method as per standard procedure. Thank you.